Okay, so today what we're going to talk about is we're going to talk about equations involving factored expressions. And for this first example, they want us to solve each equation for x. For a, they have x minus 10 is equal to 0. So in order to get x by itself, what we have to do on both sides is we have to do the opposite. So we have minus 10, x minus 10. So we're going to have to add 10 on both sides. So add 10. And add 10. So we get that x is equal to 10. So then what we're going to have to do is in our solution set, in our curly brackets, we're going to say that that solution is 10. Now let's go on to the next one. We have x divided by 2 plus 20 is equal to 0. So what we're going to have to do first on both sides is subtract 20. So if we subtract 20, and then subtract 20. Then what we're going to get is this 20 will cancel. 20 minus 20 will cancel. So we'll just get that x over 2 is equal to 0 minus 20 is a negative 20. So now we have x divided by 2 is equal to negative 20. So we want to get what x is. So instead of dividing by 2 on both sides, we're going to do the opposite and multiply by 2, multiply by 2. So this 2 will cancel with this 2. We'll just get x is equal to negative 20 times 2 is negative 40. So we get that x is equal to negative 40. So then our solution set will be negative 40. For part C, it says, demanding Dwight insists that you give him two solutions to the following equation. We have x minus 10 times x over 2 plus 20 is equal to 0. So again, we have multiplication in between these two quantities. So since we have multiplication, the only way that we can get the whole equation to equal 0 is if either x minus 10 is equal to 0 or x over 2 plus 20 is equal to 0. So, looking at this, let's give them two solutions. So, looking at this, if we had x minus 10 times x over 2 plus 20 is equal to 0. We could have that x minus 10 is equal to 0. Or we can have that x over 2 plus 20 is equal to 0. So if we have that, again, we know what the solution is. X minus 10 is equal to 0. We just solved up here. So we know that x is going to be equal to 10. And we just solved this one. X divided by 2 plus 20 is equal to 0 there. We know that x is going to be equal to negative 40. So those are our two solutions. So on the side, we can write our solution set. So in our curly brackets, we'll write them, again, we have to write them from least to greatest. So it would be negative 40 first, 10. Okay? So, from this, we can see that if we have two quantities that are multiplied together to equal 0, either the first quantity has to equal 0 or the second quantity has to be 0. So now let's look at the next one. So now we have demanding Dwight again. He now wants 5 solutions to the following equation. So we have x minus 10 times 2x plus 6 times x squared minus 36 times x squared plus 10 times x over 2 plus 20 is equal to 0. So in order for this whole equation to equal 0, so this whole left expression to equal 0, we're going to have to set each one of these expressions equal to 0. Because if we want to provide them with 5 solutions, we can have x minus 10 is equal to 0, or we can have 2x plus 6 is equal to 0, or we can have that x squared minus 36 is equal to 0, or we can have x squared plus 10 is equal to 0, or we can have that x over 2 plus 20 is equal to 0. So we have all these equations that we can solve for. But we already know what our solution is for x minus 10 is equal to 0 because we just did it up there. So we know that x could equal 0, or x could equal not 0, x could equal 10, if we have 2x plus 6 is equal to 0, and we want to solve that for x, we could subtract 6 on both sides. Subtract 6. So we get that 2x is equal to negative 6. And then if we wanted to solve for x, all we have to do is just divide by 2 on both sides. So divide by 2, divide by 2. We get that x is equal to negative 3. Okay? Now for our next one, we have x squared minus 36 is equal to 0. So looking at this, we're going to add 36 on both sides. So we get that x squared is equal to 0 plus 36 is 36. And then since we have x squared and we want to get x, what we're going to have to do is just take the square root of both sides. So we get the square root of x squared is just x is equal to, and remember when you take the square root of a number, the square root is going to be a positive and a negative 6. Because you have to take, when you take the square root, you have to take the positive case and the negative case. Now let's move on to the next one. We have x squared plus 10 is equal to 0. So on both sides, we're going to subtract 10. Subtract 10. So we're going to get that x squared is equal to negative 10. And then since we have x squared and we want to get x, we're going to try to take the square root of both sides. In here we get that the square root of x squared is x, but we can't take the square root of a negative number. We can only take the square root of a positive number. So what we're going to do is we're just going to reject this solution because we cannot take the square root of a negative number. So, now let's look at the last one. We have x over 2 plus 20 is equal to 0. And up here, we already solved that one. So we could say that x is equal to negative 40. So, now we have one solution, two solutions. Positive 6 is 3 solutions. Negative 6 would be 4 solutions. And x is equal to negative 40 would be the fifth solution. So, what we could do is we can write our solution set. I'm going to write it below here. And we have to write them from least to greatest. So the least one would be negative 40. Then we have negative 6. Then we have negative 3. Then we have positive 6. And then we have positive 10. So now we have 1, 2, 3, 4, 5 solutions. And now we have to look at the next question. It says, do you think there might be a sixth solution? So if there were to be a sixth solution, it would be in this one that we just rejected. But the sixth solution, we know that it can't be, we can't have as the square root of a negative 10. So what we're going to say is that there are exactly 5 solutions. Because there can't be a sixth one because we can't take the square root of a negative number here. Okay? So now let's look at the next one. They want us to consider this equation, x minus 4 times x plus 3. So remember that there's multiplication in between there. And that's equal to 0. So they want us to rewrite the equation as a compound statement. So we're going to have that either two things could happen then. X minus 4 could equal 0, or x plus 3 will equal 0, because that will make the whole left side equal to 0.
Alexia Bowden, could you please come to the main office? Alexia Bowden to the main office.
Alright, so moving on. So we have x minus 4 is equal to 0, or we can have that x plus 3 is equal to 0. So now, looking at this, that we just rewrote this whole equation as two compound statements. That x minus 4 could equal 0, or x plus 3 is equal to 0. So now for f, they want us to find the two solutions. So we're going to have x minus 4 is equal to 0, or we're going to have that x plus 3 is equal to 0. To solve this one, x minus 4 is equal to 0, we're going to add 4 on both sides. Add 4. So we get that x is equal to 4. Or we'll have subtract 3 on both sides. So we'll get that x is equal to negative 3. So there's our two solutions. So then if we want to define the two solutions, we did. So now let's write it in set notation. So in set notation here, we're going to have negative 3 first, and then we'll have positive 4. Okay? So now let's move on to example 1. So example 1, right here, it says, solve 2x squared minus 10x is equal to 0 for x. But now looking at this, if I rewrite it, 2x squared minus 10x is equal to 0, we don't have multiplication in the middle. We have a minus symbol. So what we're going to have to do is we're going to have to factor the left expression. And when we say factor, we're just looking for what's common in both of those terms, and then we're going to factor it out. But if we have 2x squared and we have a negative 10x, what's common between the two terms is this x. So we can factor out that x. So I'm just going to factor out 1x. So if we have 2x squared divided by x, 2 divided by, remember there could be a 1 here. Okay? 2 divided by 1 is just 2. X squared divided by x is just x. And then we have a minus negative 10 divided by 1 is a minus 10. X divided by x is just 1, which is just a negative 10 then. And that's equal to 0. Okay? So I'm just going to get rid of this 1 because we know it's there. Okay? So now we do have multiplication in the middle. So now we have x times 2x minus 10 is equal to 0. And the only way for this left expression to be equal to 0 is if either x is equal to 0 or 2x minus 10 is equal to 0. So we're going to have that x is equal to 0, or we'll have that 2x minus 10 is equal to 0. So then looking at this, what we're going to have to do is we already solved this first one. So x is equal to 0 would be one solution. Now let's go through and solve the one on the right. So we have 2x minus 10 is equal to 0. So we're going to have to add 10 on both sides. Add 10. So we get that 2x is equal to 10. If we have 2x is equal to 10, what we're going to have to do is divide by 2 on both sides. Divide by 2, divide by 2. And we get that x is equal to 5. Okay. So now we have our two solutions. We have that x is equal to 0. So if we substitute 0 in, we would get 0. Or if we substituted in 5 for x, we would also get 0. So our two solutions, so we can write it in set notation. We write it from least to greatest, so 0 would go first, then 5. So we have 0, 5. So now looking at example 2, we have x times x minus 3 plus 5 times x minus 3 is equal to 0. And we want to solve that for x. So looking at this, if we have our x times x minus 3 plus 5 times x minus 3 is equal to 0, what we would have here is we're going to look at, do we have multiplication in the middle? No. We have addition. So if we have addition, we're going to have to factor out. So what can we factor out in both these terms here? We can factor out this x minus 3 in both of these terms because it's common in both. So I'm going to factor out that x minus 3. If you divide out the x minus 3, it will cancel. So we'll just get x plus this 5 times x minus 3. If we're dividing by x minus 3, it will cancel. And we'll just get 5 is equal to 0. So now if we look at this, in order for this equation, or the left side to equal 0, we'd have to set each one of these expressions equal to 0. So we'll have that x minus 3 could equal 0, or x plus 5 is equal to 0. So then if we're looking at this, we're going to add 3 on both sides. So add 3, add 3. So we get that x is equal to 3. Or we'll have, in this case, we're going to subtract 5. Subtract 5. So we get that x is equal to negative 5. So now we have our two solutions, that x is equal to -5 or x is equal to 3. So now if we write it in set notation, we would have -5 first because we're writing them from least to greatest, and then 3. So we have -5, 3. So now looking at this, let's move on to exercise 2 to 7. So we're going to use example 1 and example 2 as a guide to help us solve exercise 2 to 7. So now looking at this, for number 2, it says x plus 1 times x plus 2 is equal to 0. And the only way that we could get that is if we set both of those expressions equal to 0. So we're going to get that x plus 1 is equal to 0. Or we'll get that x plus 2 is equal to 0. So then what we have to do is just let's solve the first one. We have x plus 1 is equal to 0. So what we could do is we could subtract 1. Subtract 1. So we get that x is equal to -1. Or if we subtract 2 on both sides, we'll get that x is equal to -2. So our solution set would be -2, -1. Because remember, we have to write in set notation from least to greatest. Looking at number 3, if we have 3x minus 2 times x plus 12 is equal to 0, either one of these expressions have to equal 0 in order for the whole expression, or the whole equation to equal 0. So we have 3x minus 2 is equal to 0, or we're going to have that x plus 12 is equal to 0. So let's go through and solve both of them. We have 3x minus 2 is equal to 0, so what we're going to do on both sides is we're going to add 2. Add 2. So we get that 3x is equal to 2. Then what we're going to do is we're going to divide by 3. Divide by 3. To get that x is equal to 2 over 3, or 2/3. And then we have x plus 12 is equal to 0. What do we have to do on both sides? We're going to subtract 12. Subtract 12. So we get x is equal to -12. So then there's our two solutions. So we have to write them from least to greatest. So in set notation, we're going to have -12, 2/3. Okay, so this is -12, looks like -72. So this would be -12, 2/3. So now looking at this one, if we're looking at it, we have x minus 3 times x minus 3 equals 0. So if we look at this, we can see that it's x minus 3 and x minus 3 are the same thing. So what we could really say is x minus 3 is equal to 0, or x minus 3 is equal to 0. But if we look at this, they're the same equation. So we just have to solve one of them. So if we add 3 to both sides, add 3, we're going to get that x is equal to 3. And that's our only solution, because for this one, x would also equal 3. So in set notation, we're just going to put 3 in our curly brackets. That is our solution to our equation. Now let's look at this next one. For number 5, it says x plus 4 times x minus 6 times x minus 10 is equal to 0. And the only way for that to happen is if we set each one of those expressions equal to 0. So we're going to have that either that x plus 4 is equal to 0, or x minus 6 is equal to 0, or x minus 10 is equal to 0. So one of those three things could happen. Now let's solve this first one. X plus 4 is equal to 0. On both sides, let's subtract 4. Subtract 4. So we get that x is equal to -4. Or, if we add 6, we'll get that x is equal to 6. or we're going to add 10, so we get that x is equal to 10. So now we have our three solutions. Now we just have to write them in set notation. So in our set notation, our solutions would be -4, 6, and 10. Okay? So now let's try number 6. So I'm just going to draw a line because I kind of went over into 6. So here I'm going to have x squared minus 6x is equal to 0. And if I look at this, I don't have multiplication in the middle. I have subtraction. So if I have subtraction or addition, and I don't have multiplication, what I'm going to have to do is I'm going to have to factor out. What's common between x squared and negative 6x is an x, just one x. So I'll factor out the x. X squared divided by x is just x. Negative 6x divided by x is a minus 6 is equal to 0. And now we have two quantities separated by multiplication that are equal to 0. And this could happen if x is equal to 0 or x minus 6 is equal to 0. So this could be that x is equal to 0, or we'll have that x minus 6 is equal to 0. So here for that first one, we have our first solution, x is equal to 0. Or if we add 6 and add 6, we get that x is equal to 6. So there's our two solutions, that x is equal to 0 or x is equal to 6. So in set notation, we'll have 0, 6. Okay? Now, for number 7, we have that x times x minus 5 plus 4 times x minus 5 is equal to 0. So in this case, what we're going to have to do is we'll have to look at, first, what do we have? We have addition in the middle. We don't have multiplication. So what could we factor out? What's common between the two quantities? X minus 5 and x minus 5. So I'm going to factor out that x minus 5. So I have x minus 5. For this first term, if we have x times x minus 5 divided by x minus 5, the x minus 5 will cancel, and we'll just get x. 4 times x minus 5, if we cancel that out, we're just going to get plus 4 is equal to 0. So now we do have multiplication in the middle, and we have that two things could happen. X minus 5 could equal 0, or x plus 4 is going to equal 0. So in this first case, what we're going to do is we're going to add 5. So let's add 5, add 5. So we get that x is equal to 5, or if we subtract 4, we'll get that x is equal to negative 4. So there's our two solutions, x is equal to 5, or x is equal to negative 4. So if we're writing it in set notation, we'll have x is equal to negative 4, or x is equal to 5. And that's the last exercise for this. Alright, so now let's move on to example 3. So if we're moving on to example 3, it says, consider the equation x minus 2 times 2x minus 3 is equal to x minus 2 times x minus 5. Lulu chooses to multiply through by 1 over x minus 2 and gets that x is equal to 8, but she's wrong. Because Poindexter points out that x is equal to 2 is also an answer, which Lulu missed. What is the problem with Lulu's approach? Well, if you look at this, if we multiply by 1 over x minus 2, we don't know whether x minus 2 is positive, x minus 2 is negative, or x minus 2 is equal to 0. And we can't have x minus 2 equal to 0, because if x minus 2 is equal to 0, then we would have 1 over 0, and we can't do that. Okay? So we'd have, if x minus 2 is, again, if x minus 2 is equal to 0, we would have that 1 divided by 0, and we know that we can't have that. So, what's the problem with Lulu's approach? Is that we can't multiply by 1 over x minus 2 because x minus 2 could be 0. And we can't divide by 0. Okay? And now it says for b they want us to use factoring to solve the original equation for x. So let's just write down the original equation. So we have x minus 2 times 2x minus 3 is equal to x minus 2 times x plus 5. So in order to do this on both sides, we want to get one of the sides of the equation to equal 0. So what could we do with this x minus 2 times x plus 5? Is we're going to subtract it away. Subtract x minus 2 times x plus 5 from both sides. So I'm going to subtract x minus 2 times x plus 5. But remember, if we did this, these would cancel and we would just get 0. But here, be careful that you don't subtract x minus 2 times x minus 2, or x minus 2 minus x minus 2. You can't cancel those out because this first one is multiplied by 2x minus 3, and this x minus 2 on the bottom is multiplied by x plus 5. So what we would get is we would just get our original x minus 2 times 2x minus 3, and then we're subtracting away x minus 2 times x plus 5. And we know that whole thing is equal to 0. So now if we look at this, do we have multiplication in the middle? No, we have subtraction. So if we have subtraction in the middle, we have to factor out what's common. What's common between the two? This x minus 2. So let's factor out that x minus 2. So I'll have x minus 2, and then I'm just going to create a bracket. And if we divide out x minus 2 here, it will cancel. So inside we'll have 2x minus 3 minus, and if we subtract away this x minus 2, we'll just be left with x plus 5 is equal to 0. So if we look at this, now inside the brackets, we have that 2x minus 3 minus x plus 5. What we could do then is distribute this negative in. So we're going to have x minus 2 times our bracket. So we're going to have that 2x minus 3. Because once we distribute this negative, we can drop the parentheses. So negative times x is just negative x. Negative times 5 is just a minus 5. And that whole thing is equal to 0. So then inside the brackets, we're going to look for like terms. So our like terms are going to be 2x and negative x. And then we'll have negative 3 and negative 5. So I'm going to have that x minus 2 is times 2x minus x is just x. Negative 3 minus 5 is a negative 8 is equal to 0. So I'm going to have x minus 2 is equal to 0 or x minus 8 is equal to 0. So I'm just going to go up over here. So we have that x minus 2 is equal to 0, or we'll have that x minus 8 is equal to 0. So if we have x minus 2 is equal to 0, I'm going to add 2 on both sides. Add 2. So we get that x is equal to 2. Or we have x minus 8 is equal to 0, so we're going to add 8 and add 8. So we get that x is equal to 8. So our two solutions are going to be 2 and 8. Okay? So, looking at this, let's move on to exercise 8. For exercise 8, they want us to use factoring to solve the equation for x. We have x minus 2 times 2x minus 3 is equal to x minus 2 times x plus 1. And if we look at this again, we want to get one of the sides of the equal sign to be 0. So what am I going to do first? I want to subtract away my left side. Subtract away x minus 2 times x plus 1. subtract away x minus 2 times x plus 1. And again, on the left side, this will cancel and we'll just get 0. But you have to be sure that you're not going to subtract x minus 2 minus x minus 2 to get 0. Because this x minus 2 is connected with this 2x plus 3. And this x minus 2 is connected with this x plus 1. So, what we're going to have here is we'll have our original x minus 2 times 2x minus 3 minus x minus 2 times x plus 1, and that's going to equal 0. So now we have to look and see, do we have multiplication in the middle? No, we have subtraction. So if we have subtraction or addition, we're going to have to factor. What's common between these two terms? This x minus 2 and x minus 2 is common in both. So what we're going to have to do is we're going to have to factor out an x minus 2. And we'll have, I'm just going to create a bracket, x minus 2 times 2x minus 3. If we divide out this x minus 2, we'll get 2x minus 3. Minus, if we divide out this x minus 2 to cancel, we'll just have x plus 1 is equal to 0. And again, if we look at this, since we have subtraction, we can distribute this negative. So distribute the negative to both terms. So we're going to get that x minus 2 times 2x minus 3. Negative times x is a minus x. Negative times 1 is a minus 1. And that's equal to 0. Now what I could do is inside my brackets, I can combine like terms. So then I can get x minus 2. And if we have 2x minus x, 2x minus x is just x. Negative 3 minus 1 is a negative 4. And that's equal to 0. So if we have x minus 2 times x minus 4 is equal to 0, what we're going to do is on both, so I'm just going to go up here, is we can have that either x minus 2 is equal to 0, or we can have that x, so I'm just going to erase it. I'm just going to move it over a little bit. So we have that x minus 2 is equal to 0, or we can have that x minus 4 is equal to 0. So if we have x minus 2 is equal to 0, we're going to add 2, so we get that x is equal to 2, or we'll have x, so we're going to add 4 on both sides, add 4, so we get that x is equal to 4. So we have x is equal to 2, or x is equal to 4, so our solution set is going to be 2, 4. Okay? So now let's look at this next one. We have x plus 2 is equal to 5. So what can we do on both sides? We're going to subtract 2. Subtract 2. So we get that x is equal to 5 minus 2 is 3. So our solution set for this one is going to be 3. Okay. And for B, we have x squared plus 2x is equal to 5x. So for this one, what we would want to do is we want to get one of the sides of the equal sign to equal 0. So what we could do on both sides is just subtract 5x on both sides. Subtract 5x. So we get that x squared, 2x minus 5x is a minus 3x is equal to 0. And now what we're going to look at is, do we have multiplication in the middle? No, we have subtraction. So if you have subtraction, what you're going to have to do is factor something out that's common. So if we have x squared and minus 3x, the common thing is x. So let's factor out an x. X squared divided by x is just x. Negative 3x divided by x is a minus 3. And that equals 0. So if we're looking at this, we now do have multiplication in the middle. So we're going to have that x can equal 0. Or we can have x minus 3 is equal to 0. So if we look at this, we have x is equal to 0 could be our solution. And if we have x minus 3 is equal to 0, we're going to add 3 on both sides to get that x is equal to 3. So our solution for this could be 0 or 3. And if it's 0 or 3, our solution set would be 0 first, then 3. Okay? And now let's look at this last one. This last one kind of gets a little complicated. But looking at this, we have x times 5x minus 20 plus 2 times 5x minus 20 is equal to 5 times 5x, 5x minus 20. So what we're going to have to do is I would just subtract minus 5 times 5x minus 20. And I'm going to do the same on this side. Minus 5 times 5x minus 20. So here these will cancel to get 0. And I'm just going to get that x times 5x minus 20 plus 2 times 5x minus 20 minus 5 times 5x minus 20 is equal to 0. So now I have addition and subtraction in the middle of these. So now what I'm going to have to do is I want to factor out what's common. What's common between them all? 5x minus 20. So if I factor out that 5x minus 20, okay, I'm going to get, if we're dividing out 5x minus 20, we'll just have x. If we divide out 5x minus 20, we'll just get plus 2. And if we divide out 5x minus 20, we're just going to get a minus 5 is equal to 0. Now what we could do in this parentheses is combine like terms. So we're going to have 5x minus 20 times x plus 2 minus 5 is a minus 3 is equal to 0. So now what we're going to have, now what we're going to have is we're going to have that 5x minus 20 could equal 0 or x minus 3 could equal 0. So we have 5x minus 20 to equal 0, or we can have x plus 3 is equal to 0. So in this case I'm going to add 20. Add 20. So we get that 5x is going to equal 20. Divide by 5. Divide by 5. So I get that x is equal to 4. Here we're going to subtract 3. Subtract 3. So we get x is equal to negative 3. So then looking at this, our solution set is going to be negative 3, 4. Okay? So now let's go on to the last page of the notes. For number 10, they want us to verify that a minus 5 times a plus 5 is equal to a squared minus 25. So if we're looking at this, we're going to take the left side, so we have a minus 5 times a plus 5, and we want to see if that's equal to a squared minus 25. So now if we do this, we're going to have to use the distributive property. I'm going to distribute the a to both of those terms, and then I'm going to distribute the negative 5 to both of those terms. So we're going to get that a, so I'm just going to do the a times a plus 5. So we have a times a plus 5 minus 5 times a plus 5 is equal to a squared minus 25. So if we look at this, we're going to then have to, again, distribute this a to both terms. A times a is a squared. A times 5 is plus 5a. Now if we distribute this negative 5 to both terms, we're going to have negative 5 times a is a minus 5a. Negative 5 times 5 is a minus 25 is equal to a squared minus 25. Now on the left side, what we want to do is we want to combine like terms. So what like terms do we have? We have 5a and negative 5a. Those will cancel, so we'll just get a squared minus 25 is equal to a squared minus 25. And now we verify that it does work. For part B, they want us to verify that x minus 88 times x plus 88 is equal to x squared minus 88 squared. So looking at this, we have that x minus 88 times x plus 88 is equal to x squared minus 88 squared. So we're going to do the exact same thing we just did in the last problem. Distribute this x to each one of these terms, and then distribute the negative 88 to each one of these terms. So I'm going to distribute this x to both of those terms, and then I'm going to distribute the negative 88 to both of those terms. So I'm going to get that x times x plus 88 minus 88 times x plus 88 is going to equal x squared minus 88 squared. And then if we look at this, we have this x. We're going to distribute this x to both of these terms. So we have x times x, which is just x squared. X times 88 is just 88x. And now we have this minus 88 times x and minus 88 times 88. We're going to have minus 88 times x is a negative 88x. Negative 88 times, or plus, negative 88 plus, or times positive 88 is going to be minus 88 squared, which is equal to x squared minus 88 squared. And then if we look at this, what we're going to do here is we combine like terms. We have positive 88x minus 88x. Those will cancel to get 0. So we're just going to get x squared minus 88 squared is equal to x squared minus 88 squared. And it worked. Okay? So now the last thing that we're going to verify for C is we want to verify the other way. That x squared, or a squared minus b squared is equal to a minus b times a plus b. So if we look at this, we have a squared minus b squared is equal to a minus b, a plus b. And make sure with this one that you always use capital letters because that's what they gave us in the original problem. If you use lowercase letters, you're talking about a totally different variable. So in this case, make sure we use all capitals. So we have a squared minus b squared is equal to, we're going to distribute the a to both of those terms. So we'll have a times a plus b. And then we're going to distribute this negative b to each one of those terms. So we're going to have negative b times a plus b. Now what we're going to do is we're going to have to distribute this a to both of these terms. A times a times b. So we're going to have a squared minus b squared is equal to a times a is just a squared. A times b is just plus ab. And then we have this minus b to both of those terms. Negative b times a is a minus ba. A negative b times positive b would be a minus b squared. And then if we look at this, we could combine like terms. Again, by the commutative property, we could say that AB and BA are the same thing. So we could rewrite this a squared minus b squared is equal to a squared plus AB. And then with the commutative property, if we have BA, it's the same thing as AB. So we're going to say minus AB minus b squared. And then if you look at these two, they will cancel out. So we get that a squared minus b squared is equal to a squared minus b squared. And it works. Okay? So now for D, they want us to solve for x squared minus 9 is equal to 5x minus 3. So if we're looking at this, if we have, using what we just did above, we have x squared minus 9. So if we have a variable, so we're just going to use c. So if we have x squared minus 9, we could rewrite this as x squared minus 3 squared is equal to 5 times x minus 3. And if we did that, we can use exactly what we just found out. It will equal a minus b, a plus b. Or in this case, x minus 3, x plus 3. So we can rewrite x squared minus 3 squared as x plus 3, x minus 3. And that's equal to 5 times x minus 3. Okay? So now we have a problem like we just had before. So if we're looking at this, I'm just going to move this up. We would have to subtract 5 times x minus 3 on both sides. Subtract 5 times x minus 3 on this side. So, because we want to get 0 on one side. So we have x plus 3, x minus 3, minus 5 times x minus 3 is equal to 0. So then if we have that, now we have to look, what do we have in between? We have subtraction, so we have to factor out. So let's factor out what's common. X minus 3 is common in both. So we're going to factor out that x minus 3. If we factor out that x minus 3, x plus 3 times x minus 3, we'll just have x plus 3. And then we have, if we subtract, we're going to subtract 5. So we'll have minus 5 is equal to 0. And then if we look at this, I'm just going to go up here. If we have x plus 3 minus 5, we can drop these parentheses. And if we have plus 3 minus 5, we're going to have x minus 2. So we'll have x minus 3 times x minus 2 is equal to 0. So we're going to set x minus 3 equal to 0 and x minus 2 equal to 0. If we add 3, we would get that x is equal to 3. And if we add 2 and add 2, we get that x is equal to 2. So those are our two solutions. So our two solutions will have 2, 3. Okay, so now let's move on to part E. So if we look at this, we want to solve for W. So I'm just going to put a line here. If we solve for W, we're going to have W plus 2 times W minus 5 is equal to W squared minus 4. Okay? And then again, using exactly what we just did up here, we could say that W squared minus 4 is the same thing as W plus 2, W minus 2. So I'm just going to rewrite this. W plus 2 times W minus 5 is equal to W plus 2, W minus 2. So now looking at this, what I'm going to do on both sides is I'm going to subtract away this W plus 2, W minus 2, so I can have 0 on the right side. So looking at this, we're going to subtract W plus 2, W minus 2, subtract W plus 2, W minus 2 on this side. The left side will just get 0. On the right, on the right side, we're going to get 0. On the left side, we're going to get W plus 2 times W minus 5 minus W plus 2 times W minus 2 is equal to 0. So now what we're going to do is we're going to have to see what we have in the middle. We have subtraction. If we have subtraction, we're going to have to factor out what's common. What's common between the two? We have W plus 2 and W plus 2. If we factor them out, let's factor out that W plus 2. If we factor out the W plus 2, in this case, if we factor out W plus 2, we'll get W minus 5. Minus, if we factor out this W plus 2, we'd have W minus 2 is equal to 0. And now what I'm going to do is I'm going to go through and solve it. So I have W plus 2, and then in parentheses, I'm going to drop the first parentheses and distribute this negative. So negative times W is a minus W. Negative times negative 2 is a positive 2. And that equals 0. So I'm just going to go down here and continue it down here. So I'm going to say part E continued. So I'm just going to take this and go down there. But looking at this, inside my brackets here, I'm going to combine like terms. So we have w minus w. So we have w minus w. They would cancel out. And we'd have negative 5 plus 2 is just negative 3. So I'm going to have w plus 2 times negative 5 plus 2 is a negative 3. And that's equal to 0. And then looking at this, since we only have a negative 3 on the outside and there's multiplication in the middle, we're going to distribute this negative 3 in. So negative 3 times w is a minus 3w. Negative 3 times 2 is just a minus 6 is equal to 0. And now if we go through and try to solve this, we're going to add 6 on both sides. Add 6, add 6. So we get negative 3w is equal to 0 plus 6 is 6. And then what we're going to do is we're going to divide by negative 3. Divide by negative 3. So we get w is equal to negative 2. Okay? And then the last thing that I'm going to do is just do this last one, number 11. So if you have this done tomorrow, it's going to show me that you rewatch this video. So looking at this, a string 60 inches long is to be laid out on a tabletop to make a rectangle of perimeter 60 inches. Write the width of the rectangle as 15 plus x, and they want to know what is an expression for its length and what is the expression for its area. What value of x gives you an area of the largest possible value? Describe the shape of the rectangle for the special value of x. So looking at this, we're just going to go through and we're going to solve, we're going to find an expression for the length, and we're going to also find the expression for the area. So if we're looking at this, if we have a rectangle, so looking at, I'll just move this over. So we have a rectangle, and it has length and it has width. We're trying to find what the length is, so I'm just going to call that L. The width, they tell us, is 15 plus x. So looking at this, we have on this side will also be length, and on this side will be 15 plus x. If we wanted to find the perimeter, we could say that the perimeter is equal to 2 length plus 2 width. Or we could just add length, the L, plus 15 plus x plus L plus 15 plus x if we wanted to. That would also give us the perimeter. We're looking for around the perimeter. So now looking at this, I'm going to substitute in my expression for length, which is just L. So perimeter is going to be equal to 2 length plus the width is 15 plus x. So we're going to have 2 times 15 plus x. So now to find our expression for length, okay, we know that for the perimeter P, we can substitute in 60 because the tabletop makes a rectangle of perimeter 60 inches. So we know that perimeter is going to equal 60. So we can say 60 is equal to 2 length plus, and then here we can distribute. 2 times 15 is 30. 2 times x would be plus 2x. So here what we're going to do is we're going to first solve for the length. So what I'm going to do first is subtract 30 on both sides. Subtract 30. 60 minus 30 is 30 is equal to 2 length plus 2x. So now if I want to get length by itself, I'm going to subtract away this 2x. Subtract 2x. So I get 30 minus 2x is equal to 2 times the length. So if we divide by 2 to get what our length is, divide by 2, we get that the length is equal to 30 divided by 2 is 15. Negative 2x divided by 2 is just minus x. So the length is going to be 15 minus x. So there's our length. If we have our area, so I'm just going to do my area formula over here. Area is equal to length times the width. And now we know that our length is 15 minus x. So we have area is equal to 15 minus x times 15 plus x. And there's our expression that we have. But if we look at this 15 minus x times 15 plus x, we could also have a different expression. But we're just going to leave our area formula just like that. And basically what we just did today, so let's look at the lesson summary at the bottom. We just used the zero product property. It says that if we have some quantity, A times B is equal to 0, then two things could happen. Either A has to equal 0, or B has to equal 0. Or we could say that A is equal to B is equal to 0. So basically if you have two quantities, A times B, you can either set A equal to 0, or B has to equal 0, or both A and B have to equal 0. Okay? And that would be the end of this lesson.